All right, welcome back to our unit on oceans or oceanography. Here we go. Our topic today is ocean currents. Okay, ocean currents are very important. Day 3 of 4, our objectives. You will know factors which influence water density. You will know the difference between surface currents and deep ocean density currents. And you will know how the surface currents and density currents connect up, forming what's known as the ocean conveyor. All right, so for your quick write, do you think we have a warm or cold ocean current off the coast of California? If you put a message in a bottle off the coast of California, where do you think it would go? Okay. All right, so go ahead and pause this while you do your quick write. I'm going to move on. All right, there's two types of ocean currents we're going to look at today. There are what we call deep water density currents, right? Okay, density. Okay, high density things sink. Low density things rise, driven by hot stuff, right? Hot, high temperature water, okay, rises while cooler, more dense water sinks, okay? Or you could think of it in salinity, okay? Saltier water is more heavy, it sinks. Less salty water is lighter, it rises, okay? So there are surface currents then up here that are powered by the wind, okay? So we have surface currents and deep water density currents. So for your notes, what are the two types of ocean currents? Question on the left-hand side, answer on the right-hand side. As always, use the answer bank to determine which words best complete the sentence here. Go ahead and pause this. I'm going to move on. Okay, first we're going to look at surface ocean currents here. So let's throw our happy sun and our Earth on here. We're going to look at some processes. Okay. If you recall, the Earth is heated unequally by the sun. Okay, it is hottest at the equator. Okay, direct solar radiation at the equator and indirect solar radiation at the poles. Okay, and if you further recall, heat travels from where? Hot to cold areas. And as a result, we get surface currents, right? Warm water wants to go to cold water, essentially. Okay, ocean currents are very important. They are like the Earth's heating and air conditioning system. Okay, they move heat from the equator to the poles by convection. Okay. Ocean currents are very important for distributing heat. Without them, the Earth would be a much colder place. Okay, so let's throw some global winds. Remember our global winds, trade winds, westerlies, and all that good stuff. And then notice the red arrow are ocean currents. Trade winds blow essentially east to west, creating a current that moves in the same direction. Remember, surface currents are powered by wind. So guess what? Trade winds create ocean currents that move in the same direction as the wind. Okay? So the Coriolis effect does something here. Okay? The Coriolis effect causes these currents to deflect or curve to the right in the northern hemisphere, and notice if you're headed this way, to the left in the southern hemisphere. To the right and to the left. Okay? So the westerlies now, okay, now force the ocean current to go in the opposite direction, okay, that blow west to east. And guess what? The ocean current also moves west to east, the same direction as the westerlies, okay. Once again, the Coriolis effect causes these currents to deflect or curve to the right in the northern hemisphere and to the left in the southern hemisphere. Notice something here. We have a pattern developing, huh? So now, okay. So warm ocean currents move heat from the equator and always flow on the east side of the continents. So on every east side of the continent, okay, on the east coast of every continent, there is a warm ocean current. Okay. Guess what's on the west side of continents? You got it. Cold water comes from the polar region and flows on the west side of continents. So cold ocean currents. What coast are we on? We're on the west coast, and you guessed it. Okay, we have a cold ocean current off our coast. Okay, so ocean currents flow clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. Okay, due to the Coriolis effect. All right, so clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. Okay, So here's the actual currents. Notice, warm, 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 cold. Canary current off of Africa. Warm, 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 and then the cold off the west coast, right? So we have this direction, okay? Counterclockwise, and then we have clockwise, okay? So notice, here's a heat map of the world here. North America, cold water coming down, getting warmed up by the sun, getting, okay, off the east coast, the warm current comes up, gets cold, and comes down, okay? Same thing over here, cold water coming down, warm water moving up, okay? You see this everywhere, okay? Cold water coming up off the west coast, getting warm, and then coming back down, okay? So you can see the clockwise and counterclockwise movement. So for your notes, what are surface currents? Question on the left-hand side, answer on the right-hand side, okay? So go ahead and write this down, okay? I'm going to pause this. Make sure you use your answer bank. I'm going to go ahead and pause this while you write. I'm going to move on. Okay, go back here. So the Gulf Stream. For as many years as ships have sailed, sailors have used surface currents, okay, to navigate the world, okay, and the global wind patterns to help, okay, get them from place to place. So during the American colonial era, ships floated on the 100-kilometer wide Gulf Stream to go from North America to England, okay? Because remember, we were in the Revolutionary War that period, and the Gulf Stream essentially got us to England, where we had to discuss terms and war treaties with England, okay? So, two types of surface currents. There's the cold California current, right? There's cold currents. There's the cold California current off our coast. And off the east coast, guess what? Remember, east coast of continents have warm currents. We have the warm Gulf Stream current. Very famous current, okay? That's why it's so humid on the east coast. And this warm current goes all the way up to Iceland and England, keeping its climate pretty warm up there, okay? So the Gulf Stream is a warm water current. Here it is off the coast of East Coast. It comes up from the equator, okay? This current keeps the climates of Iceland and Great Britain, England, pretty mild or moderate, warmer than they should be. So remember, warm ocean currents create warmer than normal climates. So for your notes, what are the two types of surface currents? Question on the left-hand side, answer on the right-hand side. Okay, go ahead and pause this, okay, while you write this down. I'm going to move on. All right, density currents. So notice we have tropical regions over here, the equator over here, and the polar regions, icebergs. It's cold stuff, right? So density currents. Warm water moves from the equator to warm water moves from the equator toward the poles, okay? So notice warm going to cold. As it moves, it gets cold, okay? So as it moves toward the poles, it begins to cool, okay? It gets colder, right? When seawater freezes, it locks out, okay, the salt, and it becomes saltier. And salty cold water is heavy or more dense. And guess what? So therefore, colder salty water sinks to the depths and brings nutrients and oxygen with it. Okay, very important. Many animals rely on this in the oceans. This density current then flows back to the equator along the ocean bottom. Okay, and the density current is complete. Okay, convection, once again, density differences. Okay, so question on the left-hand side, what are density currents? Answer on the right-hand side. Go ahead and pause this while you write. I'm going to move on. Okay, the last thing we're going to talk about today is the Thermohaline Conveyor. Okay, it is a global circulation of ocean water that combines warm surface currents and cold deep water density currents. So these things meet up. Okay, and it distributes water. It's a very important current for moving oxygen and nutrients throughout our world's ocean. If this thing shuts down, most of the life in our oceans will die with it and shut down with this current. Okay, so very important. This deep water density current is called the Thermohaline Conveyor. Remember, thermo means temperature or heat. Thermo, temperature, right? Thermometer. And haline is salt. Halite is the mineral salt. So thermohaline, temperature and salinity current, essentially, right? The two things that regulate ocean water density. Okay? Colors in blue indicate saltier, colder, dense currents. Okay? Heavy, dense water. And colors in red indicate warmer, less dense surface currents. Okay? So, for your notes, What is the thermohaline conveyor? Question on the left-hand side, answer on the right-hand side. Okay, use the answer bank as always to determine which words best complete this sentence. Go ahead and pause this while you write. I'm going to move on. Okay, so summarize here. You can always do your own, or you can do mine. Okay, look back at your notes and try to determine, okay, what these blanks are, okay, for 20 points. Okay, go ahead and pause this while you write, and we'll see you next time for day 4 of 4.